A mechanical computer is built from mechanical components such as levers and gears, rather than electronic components. The most common examples are adding machines and mechanical counters, which use the turning of gears to increment output displays. More complex examples could carry out multiplication and division. Friden used a moving head which paused at each column, and even differential analysis. One model sold in the 1960s calculated square roots. Mechanical computers reached their zenith during World War II, when they formed the basis of complex bombsights including the Norden, as well as the similar devices for ship computations such as the US Torpedo Data Computer or British Admiralty Fire Control Table. Noteworthy are mechanical flight instruments for early spacecraft, which provided their computed output not in the form of digits, but through the displacements of indicator surfaces. From Yuri Gagarin's first manned spaceflight until 2002, every manned Soviet and Russian spacecraft Vostok, Voskhod and Soyuz was equipped with a Globus instrument showing the apparent movement of the Earth under the spacecraft through the displacement of a miniature terrestrial globe, plus latitude and longitude indicators. Mechanical computers continued to be used into the 1960s, but were quickly replaced by electronic calculators. Virtua with cathode ray tube output emerged in the mid-1960s. The evolution culminated in the 1970s with the introduction of inexpensive handheld electronic calculators. Mechanical computers were ailing in the 1970s and dead by the 1980s. Examples: the Antikythera mechanism, c. 100 BC, Pascalin, 1642 Blaise Pascal's arithmetic machine primarily intended as an adding machine which could add and subtract two numbers directly, as well as multiply and divide by repetition. Stepped reckoner, 1672 Gottfried Wilhelm Leibniz's mechanical calculator that could add, subtract, multiply, and divide. Difference engine, 1822 Charles Babbage's mechanical device to calculate polynomials. Analytical engine, 1837 a later Charles Babbage device that could be said to encapsulate most of the elements of modern computers. Ball and disk integrator, 1886, William Thomson used it in his harmonic analyzer to measure tide heights by calculating coefficients of a Fourier series. Marchant calculator, 1918 most advanced of the mechanical calculators. The key design was by Carl Friden. Kerosene predictor, Z1, 1938 by Konrad Zuse. Curta calculator, 1948, Moniac, 1949 an analog computer used to model or simulate the UK economy. Voskhod spacecraft Globus IMP navigation instrument, early 1960s, GComp I, 1963, an educational 3-bit digital computer, Dr. NIM, mid-1960s, a mechanical computer that plays the game NIM, GComp II, mid-1960s, a rolling ball digital computer, Automaton mechanical devices that, in some cases, can store data and perform calculations, and perform other complicated tasks. Electromechanical computers. Early electrically powered computers constructed from switches and relays rather than vacuum tubes or transistors are classified as electromechanical computers. Examples include, Z2, 1939, Z3, 1941 designed by Konrad Zuse. Harvard Mark I, 1944 built by IBM. Harvard Mark II, 1947, binary arithmetic relay calculator Bach, 1950, Simon, 1950, Bell Labs Mark VI, binary electronic sequence calculator BESK, 1953, Harry Porter's relay computer, Portland State University, 2005, 1. See also, domino computer, billiard ball computer, mechanical calculator, history of computing hardware, Turing completeness, analog computer.